So we're here at E-Ink at IFA 2012. So you have a whole bunch of new demos here.
Yeah, we have a lot of demos. Let's start with the kind of products that we've had the most success in the last several years. Here's an example of currently shipping e-paper display. This is the E-Ink Pearl display in the Barnes & Noble Nook. And you can, it's a touchscreen based device, and you can see it's quite fast. And we've been claiming in the last few years that our displays actually began to look better than paper, better than paperback book, better than newspaper. And one of the advantages with this particular product is that in the past we said our displays work great outdoors, like you can use them in the beach. Now we can also use them in the bedroom. So what does that mean? We have a front light that our customers installed in the device. When you can see that, let me switch off the front light and switch it back on so you can see the impact. So this is kind of what it will look like when in darkness, and you can turn the light on and you can see that you have a very cool light, very soothing, and it still has a long battery life, and you can you can read for many hours with this technology, and it's no longer limited just to the beach.
This front light technology, is that E-Ink technology, or anybody can just add some light and...
So E-Ink does have some front light technology, but E-Ink also has customers that build their own front lights for their different products. Either way, the idea is to use our displays in low ambient environment, and that front light achieves that. This is like the equivalent of a backlight for an LCD. So that is one of the examples of a shipping product. Here's a device from Bookin, and you can see they've got some fairly quick transitions, and they can actually run videos on this, and I will show you an example of an e-paper video in just a moment. There you go.
So they use, for example, Neonode IR touch, or they use capacitive?
Each of our customers has different type of touchscreens and different vendors that they use. We are sort of technology agnostic to a most part. What we don't like is any layers on top of the display. We don't want light being impeded going into the display. So technologies that do not put a layer on top of the display, that are operating with sensors on the sides and so on and so forth, whether it's IR, whether it's some other technology.
Was this one capacitive? It was IR?
I don't know about this particular...
But it's possible to do capacitive, that looks good.
Absolutely. You can do capacitive, that will look good. IR, of course, and there are several other technologies that can be employed. I'm going to show you some of the other examples. So we are able to do front lights. You can see that the speed of the display has improved to the point where we can actually do animation. I'm going to run animation on a device here for you that was created for us using a chip from Epson. This is the standard E-Ink display that is going to run this animation. Let me step aside so that you can see the animation.
Welcome to Huma Huma Nuka Nuka Apua Island.
So what's the frame rate on this?
That's only 8 frames per second, but still you can run fairly good animation. We're not quite video ready yet, but we can definitely do animation. And for lots of the children's books and things like that, the animation that we have is more than ample.
So, because refreshing 8 times per second, does it use much more power than if you refresh once every minute, right?
Absolutely, it does. So the advantage of the technology really is that when you don't refresh the page, when you have the exact same image on it, it consumes zero power. That's why it lasts very long. But in a video kind of environment, it will consume more. But still, it is significantly lower than LCD. The reason is very simple. We have the ability only to animate those portions of the screen that needs to be animated. All the background can remain still, meaning you're not consuming power for those pixels that are in the background. So there are a lot of very interesting things that you can do. For example, if you imagine an electronic textbook, kind of like the Ectaco Jetbook, for example, which is being shipped in the market, you could potentially take a corner of such a display and animate it. So imagine you're reading a book and you have an image on one corner. You can animate that image, and the rest of it is black and white text that remains still, doesn't consume any power. and you may be watching that animation for a while, so 80% of your screen is probably not consuming any power, so the device overall still is very low power.
So it can last for many hours like this in an e-reader, right?
Absolutely.
More than 5 hours.
Definitely more than 5 hours. And most of these devices without a front light have been advertised as lasting for 2 months on a single charge. And with the front light, obviously, the light, depending on how much of light you're using, it will reduce. Still, we're talking about days or weeks rather than hours or minutes with other display technologies.
So which part of this did Epson do? Is some of the chips here?
Epson made the chip to drive the display.
This one?
We make, yes, I'm not sure you can see it quite well. That is a chip, and it's fairly small. They are very good at designing some really very small format chips.
Is there Epson in a lot of the devices or on the market?
Epson was one of the first companies to work with us when the semiconductor industry had not paid attention to e-paper. I'm talking about a few years ago. Epson was one of the first ones to step up and build what was known at that time as the broadsheet. That was the first chip. It was very successful. Pretty much they had the entire market. Subsequently, we also have Marvell, we have Texas Instruments, we have Freescale, we have Samsung and others that are also in the market. But Epson still continues to enjoy a decent share of the market. They have multiple products, not only for the monochrome displays, they also have products for our color Triton displays.
Is it ARM-based?
I believe yes.
All these, what's called drivers, e-ink controllers, they all mostly ARM?
Most of them are, yes. The original ones were not, they were dedicated controllers, they were not SoCs, and they would have an external SD-RAM and flash and so on and so forth. Now they're all integrated into one single system on chip package. I'm going to show you another improvement that we made in our product. There are three things that people typically ask us. They say, what about speed? And I showed you animation. That's probably one of the fastest we've achieved, both in page turns as well as you saw the animation video running. The second thing that we get asked about is color. So I have here, you've seen the Triton 1 sample from before. And the Triton 1 sample is, the Triton 1 display is what is being used in the current e-readers, like the JetBook and the Hanmang device and so on and so forth. This is the Triton 2 example. What we did here was to increase the color saturation, we increased the size of the pixels. So once you increase the size of the pixels, they're not really that suitable for reading because you want much smaller pixels. But this size pixel, this is a 0.5 millimeter pixel display, and they work perfectly fine for signage type applications where you're not viewing the display from a few feet, you're viewing them from several feet away. In fact, you're shooting this from a little bit closer than where we would expect viewers to look at it. But if you're 5 or 6 or 8 feet away, all of a sudden you notice that you don't see these pixels anymore, and the display looks much more better. And if I take this outdoors, this display will look absolutely gorgeous, and the color saturation will reach something similar to what we're seeing with LCD. Obviously, LCD starts washing out outdoors, and our display looks absolutely gorgeous. And the other advantages are, in high ambient, LCD consumes more power because they're trying to fight the sun by cranking up the backlight. In our case, we don't consume any more power. It's the exact same power, which is very low power. In this particular case, it's exactly zero power because I'm not changing this image.
So it's kind of revolutionary for the whole advertising billboards and all that.
Absolutely. We believe that the signage is going to be one of those very large and interesting markets for e-ink with this technology, where we are hoping to put these very large displays. I'm talking about several feet in diagonal, either tiled or monolithic type displays in outdoor applications that are extremely thin, consume very low power, and sunlight is not an issue. Most current technologies generate a lot of heat, and then they need to be heated when it's very cold, all kinds of issues with those. We will have some of it, but not to the same extent. Our displays are going to be a lot more rugged, and because it's so light that you don't need to have a steel pole to mount our displays. That's sort of one of the other benefits that we will see with this technology.
So it's going to be affordable enough to buy like 10 meters and... put it up in the highways?
Not today, but I'm sure that is the direction it'll go. So if you think about our product compared to LCD, LCD's largest factory makes a 10 by 10 mother glass, and then you cut them down into different sizes, so on and so forth. But to ship, those are not cheap. They're very expensive. And in our case, we have a few feet diagonal, a few feet wide display that we can go a kilometer long with, and it's made in rolls, so you can ship them much more easily, and you can assemble them into products that can be put into these signage type applications much more easily than a sheet of glass that is somewhat rigid. So that is the example of color. What we also did was we said, if we take advantage of our front light technology, and this is Triton 2, with Triton 1, our existing shipping product, we are able to create a demo like this. And you can see we have a children's book with a front light on it. And let me first switch off the light, and you can see the impact of this. So you can see the color still shows up, and it reads just like a book. It has that natural, very good digital reading experience. But once you switch on the light, the colors start popping because you're putting more light into the system. That's what our display is like. Unlike technologies that emit light, we like more light you have, the better it is for us. So that's what we've achieved with color. I'm going to talk to you about flexible displays now. So we've been on the quest of building flexible displays for a long time. We build them with different kinds of materials, whether it's plastic and other type of materials. And here's an example of an e-ink built flexible display, and I've actually bent it. You can see the shape here. The idea is not to flex it constantly because there's ITO layers on it that may not like it, but the display itself, the plastic, is pretty rigid.
What layers did you say that might not like it?
The indium tin oxide layers on top don't like to be flexed a whole lot. But the idea is not to keep flexing back and forth. The biggest advantage is that they're very rugged like paper, right? I'm going to drop this to show you that you can break this. Now the challenge for you is to see if you can track this display all the way when it falls down. I probably have to repeat that. Did you get it? Or,
Yeah, I got it.
Okay, so you can break this. Now, what is interesting is we've been showing these kind of prototypes for a while, right? And you can probably build almost anything in the lab one time. Can you make this in production is really the issue, and can you commercialize it? Can take full advantage of the technology? And we've made progress. We have been able to build this display in mass production quantities that are being shipped today, and I'm going to show you an actual device that has been commercialized by our customer. And here's a device from Wexler, and this you can see from an angle it's a curved device, and it's an e-reader. It has a e-ink flexible display with all of the drive electronics in the spine here, and if you look at the profile from the back, you can see it's very thin, and all of the electronics is right here on the bottom. Again, I'm going to do the same thing that I did with the other one, which is the purpose of this is not to constantly flex. It'll flex a little bit, that's not the intent. It is basically very, very rugged display, and you can't break that display. And and also, the other advantage that we haven't talked about a whole lot, which is as these devices get larger, when you have like a 8.5 by 11, that sort of thing, the weight of the glass all of a sudden becomes substantial enough that you need both your hands to hold it. Most tablets are like that. You can hold them with one hand, maybe for a few minutes, not for long. But if you want to write on the display, you would need to hold it with one hand and to highlight, annotate, so on and so forth. So that's why these flexible displays become much more important. It's not just it's rugged; it's extremely light, and for reading applications, it takes full benefit of the digital readability of the display. So I know on your video it's very hard to say how much this weighs, but I can tell you it weighs almost next to nothing. Definitely it weighs a lot less than a paperback book.
And the quality of the reader is like glass?
It is our Pearl display, so it is exact same display, exact same chemistry, exact same microcapsules that are already being shipped in millions and millions of units.
But that you have plastic on the top, it doesn't bother in terms of readability at all?
No, it doesn't. As you can see, I will show you what it looks like. The image looks pretty darn good. well, even in low lighting conditions, it looks fairly good. So I don't believe there is any deterioration in image going from glass to.
It could be done even smaller, no more compact. You could put stuff away
You,
a bit. Or...
you could, but think about it. These guys are pioneers. They've devised one of the first devices in the world that makes use of mass-produced. And you will see them at this trade show, the IFA show, and they have on their booth a lot of. There's a lot of different colors and all kinds of different features.
Waterproof?
I don't think so. No? Not yet. We'll get there someday. But I also want to show you another example of where we are trying to use flexible display in a completely new environment. So we have built these devices that are, we believe will become secondary displays on mobile phones. So if you, I have dummy displays in the back, and I'm going to show you the dummy displays so you know what I'm talking about. Most of your phones kind of look like this, right? They have LCD, and it doesn't matter what type of phone, you've got an LCD and it occupies a lot of the room. The back of the phone is usually a sheet of plastic or a sheet of metal, and that space is real estate that's not used. So we want to use that real estate to put e-ink displays that are extremely thin, will hardly take up any room, and they're very low power. So the advantage here is that with most of the LCD type products, let's say you put your boarding pass on one of these phones. When you're standing in line, it's quite possible you're running out of juice on your phone, or there's no Wi-Fi connection, or all kinds of issues, and you end up having all kinds of problems with it. Whereas we can put an image on the display, even if it has zero power, your completely battery is drained out, it'll still retain that image, and you can still scan it and use it as a boarding pass. There are several other applications that you can use this for, whether it's to provide coupons, whether it's to provide directions, and finally, what we hope this will achieve for us is people that want to read on their phones no longer have to use the LCD that's emitting light at them, and if they start using the LCD, they're going to be run out of power by the time they're done with chapter 1, whereas you can read a lot on the e-paper display, and it's a better reading experience with this technology.
So how soon?
We are in the process, we have developed the product already, we are in the process of working with customers to launch it, and so I would say in a few months we should hear about initial launches of products.
Do you envision that all high-end Android, iPhone, all that, they should all basically have this? It's going to be default.
If it is my wish, absolutely. But you know, like with any customer, a single mobile phone manufacturer has hundreds of different models. So it takes a while for them to figure out and realize the benefits. And so essentially what you can have is for companies that want to monetize, right? The mobile phone companies and the carriers can start monetizing with this display. They can put coupons in it, they can have advertisements in it, they have, and I'll talk about another example of something which you know, I always find this very interesting. If you go to a typical mall, for example in the US, you have a kiosk which sells a lot of these templates that typically teenagers buy and strap them on the phone. It gives a unique shape or design or color that may individualizes the phone for them. And we can do that one too. With the display, you can create a certain pattern, you can put images, you can put the picture of your favorite cat on this device. And you could do that with LCD as well. A lot of people do. Unfortunately, your cat will consume all the power if you keep looking at the cat's picture on one of the LCD devices. Whereas on this, it will consume zero power once you put the image on.
You would need to do a bunch of work to like choose to have this size and mass manufacture it. It's kind of easy to like say I want this or that and just make a few 100,000, or how does it work exactly?
With a matrix type display, a diagonal size is very important to pick. So we'll pick those based on our customer recommendations, what's the right size. So to give you an example, we had an existing mask where we could produce something like this, right? This is the standard size we are able to produce. We're able to produce other sizes to 5 inch, 6 inch, so on and so forth. The exact size of the display in some ways does not matter. We can indeed produce it, but we need to make sure that we're picking those right sizes that have the volumes. So if we pick sizes that have small volume, then we are spending money on initial tooling and stuff like that.
So it might be 4 inch, might be 4.3, might be something like that.
Correct. Whatever makes the most sense for a customer we can produce that exact
And that can be
dimension.
plastic.
We can make it in plastic, we can make it in glass. I'm going to show you the examples of how we exactly do this. So these are real displays, by the way. They are not fake displays. They are really ink displays. I actually have one of those displays right here. It is running in that particular example.
Would it even be touch?
Yes, it could even be touch if you wanted to. So here's an example of what it looks like. Let me get back here in the light, you can see it a little bit better. And in this particular case, it's a real ink display that was used in that secondary phone example. And that is a display in the back. In the front, we have a protective material just to give it some hardness and make it very rugged. Now, the actual display is a lot thinner than this. Not that this is that thick. I don't know how well you can tell from this, but it's extremely thin. I would say this is about roughly 1 millimeter in thickness total, including this protection. But the display itself is a fraction of that, and I'm going to show you an example of what the display itself looks like. So let me pick up this one too, so you can see all three of those. So this is the actual display. It is almost the thickness of 2 sheets of paper, and it's flexible. And that display has a protective layer on top in this particular example. It doesn't have to. In some examples, you probably don't need that sort of a protective layer. And then it goes into a device like this. And it does not make the cell phone any heavier. It does not hardly use any thickness. You can see without the protective layer, this is very, very thin and doesn't consume hardly any power. It is sunlight readable, and you now have a few different options on your mobile phone that you never had before. And basically, if you're using real estate in the back of the phone, that today is wasted.
So what's the difference in price between the plastic back on the phone and this back? Can you say approximately? I mean, this is going to be like, can you give some idea?
I don't know the exact price yet, because it's very simple that it's not just the display alone, right? So you have to put some images on it, you have to put content on it, so there's going to be software, there's going to be all sorts of things. So it's more than just the display. So I really don't know the price yet. But as soon as our customer launches the first product, we will have the pricing, and so I will let them make the announcement about what the actual cost is. Let me now show you examples of so far I've shown you most of our matrix displays that are so many pixels by so many pixels that are used in e-readers, mobile phones, so on and so forth. I'm going to show you an example of our segmented displays that we are using in some few different applications. This is an example of segmented display where we've cut it into a unique shape. Entire display, you can see, is fairly thin and extremely rugged. And obviously I can drop it, I can stomp on it, it's not going to break. So I have in my pocket a sample of this exact display, which I had previously put an image on, and I've unplugged it. There's no battery in this, and it's not just that you can drop it on the floor. This is so rugged that you can attempt to kill it if you want, and I'm going to stomp on it, and it's not going to break. If you feel like you can stomp on it better, you're welcome to do so and see if you can break it. There you go. Clearly you have not broken it because the image still is retained on the display. And I can put the display back in here, and you can see that I can light it back and it'll work fine. So let me stick this display back here in this driver box, and we'll connect it back. There it is. And first it's going to blank out the screen and start that image all over again. You can see that the e-ink logo came up, and it says these displays are used for icons, whether it's battery indicator, whether it's the strength of the signal on your mobile phone, and we can overlap characters, and you can put numeric data, and it's going to count down. So obviously the display is working, and it's very, very rugged. So we are looking at other concept type of devices where we can use this display. One of the examples is today in a hand drill, a power drill, you have no idea how much battery is left when you pick it up. And you can tell when it's fully charged or when it's discharged based on the little red LED, whether it's green or red. And even if it's green, you don't know whether you have 10% charge or 80% charge. So we can put an e-ink display. And what this display essentially does is, first of all, it gives you battery capacity. And that part is easy. It can tell you what direction the drill is going. And then it can also give you whatever other information you want. And basically this display will go on the device without increasing thickness. It will make a really cool looking...
So it's not shipping yet?
It's not shipping yet. So what we do is, with our technology, we can put them in a lot of different applications. See, our goal is e-ink on every smart surface. So this surface was not smart. It was a dumb surface before we put the display. All of a sudden, the surface has become smart. The smartness already existed in a lot of these devices. We're just bringing it to surface and exhibiting that smartness in these devices. And I'm going to give you another example of a product which is shipping. This is made by Motorola. It's a two-way pager. So the employees can get messages on this, and they can probably hang it on their shirt. And let me turn it around so you can see the images better. They can get information back and forth, and they can communicate back to the office, particularly in locations where they're mobile and they need to correspond with somebody. So again, very low power, sunlight readable type segmented display. Finally, I'm going to show you an example of an industry where we're seeing a lot of progress. So we've been making these plastic displays that go underneath a overlay, color overlay. And essentially they are point of purchase displays that are put next to products on the shelves in retail environment. And we've seen a lot of lift in sales based on this technology. And in this particular example, we are advertising the Jack Daniel's brand with an image. So when this display is put next to the product, it attracts attention, and it's a point of purchase type device. I'm giving you another example here of a product that where we can show a perception of motion with this type of display. So our customer, a company called Motion Display based out of Sweden, created something fairly intelligent. So what they did was they said, if they create a generic display like this, you can see it can be mounted to a shelf. They've got, you can see that the product has these rails, and it'll actually go on a retail shelf. And when they want to advertise, for example, in this case, the Purina brand, they just put this color overlay. And when they're done with this, they can actually remove this overlay. They can pull it out, and what they can do is they can now say, okay, we're now going to have, let me see if I can do this. I may be a bit clumsy, but so they can say, we're now going to advertise Coca-Cola. So the retailer can buy one of these devices or several of these devices, but they can switch out these overlays depending on what they're promoting in that particular time. It gives a lot of flexibility for the customer to advertise a lot of products. You can see several examples, whether you have the Lay's chips or the Toblerone candy and so on and so forth. You can have a lot of these overlays to advertise.
Can you customize what happens behind it? Just blinks.
You can customize what happens behind. There are different kinds of sequences you can go through, and you can pick the sequence to match that particular overlay.
So how many stores are actually using e-ink, like throughout the whole supermarket? Is it still happening?
It's thousands and thousands of stores. We have been shipping tens of thousands of these sorts of displays. We have customers that actually take our display and produce the graphics that create these plastic overlays. They make the driver assembly. This has got a battery in the back, and once you snap on the battery, the display comes alive.
For many months?
For many months. Typically they last for 6 months. Many of them last for much longer than that.
So once every 6 months you go in and change the battery?
In this particular case, you don't even need to change the battery. There's a USB drive, you can just charge it and work. And there are other cases where you can use a AA battery, you just remove it.
So in which countries do you have all these stores?
We have them worldwide. Most places where we've seen traction are in Europe and to some extent North America as well. And these are with top brand names, companies that are able to show proof that when they have this, we call this product ink in motion, because our product shows perception of motion. The ink in motion products actually lift sales. And we've shown examples where, whether it's a retail product, whether it's a soft drink, whether it's a candy bar and some other products, compared to others that are not accompanied with these signs, we're able to lift the sales sometimes at 50-60%. So even if you lift the sales by 5 or 10%, it more than pays for the investment in creating one of these devices, and it lasts for a very, very long time, and you can reuse them as well. So those are sort of some of all of the examples that I've got today. I think the key message for us is we've been very successful in the e-reader space. We've got multiple products, and customers are continuing to build new products and launching in the market. We've seen many varieties of e-readers, whether they have touchscreen devices, they have faster page turns, they have front light technologies. Now we are diversifying into a lot of other markets. We started with the Surf product line, where we started going into these applications like, the traditional wristwatch that uses the e-ink display, to smart cards, to shelf labels, and so on and so forth. Now more recently, we are able to produce products like the Triton color display that I showed you to go into signage type applications, where we can create fairly large displays, tile displays, as well as some monolithic larger displays that can be used in outdoor type applications.
All right, so e-ink is growing, right?
E-ink is continuing to grow in a variety of different applications. Our challenge mostly is, if we have 50 things in front of us, which are those 3 or 4 or 5 things that we can bet on? And it's one of those fun opportunities to be able to target those applications.
Cool. So I'm looking forward to have an e-ink on the back of the Galaxy Nexus. Take this one off. There we go.
Pop open the back cover, and you can put an e-ink display on it. Sure.
That's gonna be cool.
Sure.